Example 3. Suppose f is a function that is continuous for all real numbers. The graph of its derivative, f prime, is shown. So this is the derivative of the function f, not the function f. A. What is the domain of the derivative function f prime? So looking at this graph, because this is the graph of f prime, what are all the x values included? Well, implied that it goes from negative infinity to infinity, looks like we have a break where there's a vertical asymptote at x equals 0, and then another break where there is a jump at x equals 2. So we can say the domain is negative infinity to 0, union 0 to 2, union 2 to infinity, where we've included the break for the vertical asymptote and the break for the jump. B. List the critical numbers of f. Now be careful here because this says of f, and we are not looking at a graph of f. We are looking at a graph of f prime, its derivative. Remember that critical numbers is where f prime equals 0 or does not exist. Where does that happen in this graph? I see f prime is 0, hitting the x-axis at negative 2, and again at positive 4. So those are two critical numbers. Where does this derivative, this graph, not exist? At the vertical asymptote and at the jump. So at x equals 0 and at x equals 2. So our critical numbers are negative 2, 0, 2, and 4. C. At what numbers x, if any, does the graph of f have a horizontal tangent line? Remember that a horizontal tangent line has a slope of 0, so the derivative equals 0. The derivative. This is a graph of the derivative, so we're looking for where this graph equals 0. And like we said for critical numbers, there are two places where that happens, negative 2 and 4. So x equals negative 2 and 4. D. At what numbers x, if any, does the graph of f have a vertical tangent line? So a vertical tangent line is a line with an undefined slope. So we would say f prime does not exist. But we have to be a little bit more specific. When there is a vertical tangent line, such as this type of picture, if the function were drawn, the slopes begin to get steeper and steeper, increasing without bound. So at a vertical tangent line, it's not just that the derivatives don't exist, but that f prime, the derivative, is unbounded. Or we can think of it as the slopes of f are increasing or decreasing without bound. We can also think of this like the limit as x approaches some x value of the derivative equals infinity or negative infinity. So again, we're looking at the graph of f prime. Where does this graph have a limit of infinity or negative infinity? At the vertical asymptote, at x equals 0, where there is a vertical asymptote on the graph of f prime. E. At what numbers x, if any, does the graph of f, again that's the graph we don't see, have a corner? Well, remember at the corner, the derivative f prime does not exist, but in a different way than when there was a vertical tangent line. When there's a corner, sharp point like that, the derivative from the left side is different than the derivative of the right side, but they both have values. They are not unbounded. So we can think of it like this. F prime is different from each side. So we can think of it like the limit of f prime as x approaches some x value from its left side does not equal the limit of f prime as x approaches some x value from its right side. So where on this graph of f prime that we're looking at is the limit from the left different than the limit from the right? That's right, at this x value of 2. X equals 2, and we think there's a jump in the graph of f prime. F. On what intervals is the graph of f increasing? Again, the graph of f increasing is when the function's derivative is positive. Now we're looking at the graph of the function's derivative f prime, so we want to think this is where f prime is above the x-axis. Where does that happen? In this section of the graph, in this section of the graph, in this section of the graph. So everywhere from -2 to 0, there's a break in the graph there, and then from 0 to 4. G. On what intervals is the graph of f decreasing? So we think where f prime is less than 0. And because we're looking at a graph of f prime, we want to think where f prime is below the x-axis. So I see this section and this section. So on those two intervals, -infinity to -2, union 4 to infinity.